Every day, someone turns on a kitchen faucet without thinking twice about it. The water just arrives, cold, steady, ready to fill a glass or a pot. But there are mornings when that routine breaks. The tap sputters instead of flows. A notice arrives warning that the water isn't safe to drink until further notice. A well that used to fill a bucket in seconds now takes minutes, then longer, then stops altogether during a dry stretch. In those moments, a system that normally disappears into the background suddenly becomes the only thing anyone can think about. For households outside municipal water networks, that uncertainty is closer to the surface. A private well rises and falls with groundwater levels no one can control. Rainwater tanks empty faster during a dry season than they refill. Even in cities, plenty of people keep a shelf of bottled water or a few filled containers in a closet, quietly aware that the supply will eventually need replacing. In every case, that first glass of water in the morning depends on something. A pipe, a pump, a season, a delivery truck. That isn't guaranteed. That uncertainty has pushed people toward a range of solutions. Some install larger storage tanks in a garage or basement. Others drill deeper wells or expand rainwater systems where local rules allow it. Portable filters, cases of bottled water, and emergency containers all have their place. Each option solves a different problem, but each also comes with its own trade-offs. The space a tank takes up, the cost of drilling, the way stored water has to be rotated and replaced before it goes stale. One idea that keeps surfacing in this conversation is pulling water directly from the air itself. Atmospheric water generators work by cooling humid air until the moisture in it condenses into liquid, the same way a cold glass of lemonade beads with water on a summer afternoon. Commercial versions already exist, from countertop units the size of a coffee maker to large industrial machines built for offices or remote job sites. Their price, power draw, and footprint shift a lot depending on what they're built for. Joseph's Well sits in a different spot on that map. It isn't a machine that shows up in a box, ready to plug in. It's a digital instructional guide that walks someone through building a smaller atmospheric water generator out of parts they gather themselves. After purchase, everything arrives digitally. Written instructions, diagrams, blueprints, and step-by-step videos that walk through the build. Instead of unboxing a finished device, the buyer opens a folder of guides meant to walk them through building one. The parts themselves, tubing, fittings, electrical components, are sourced separately from hardware stores or online suppliers, piece by piece, according to the materials list in the guide. The physics behind it is the same physics behind any dehumidifier or cold glass on a humid day. Air holds water vapor, more or less depending on the temperature and humidity around it. Cool that air down past its dew point, and the moisture has nowhere to go but into liquid form, collecting as droplets. The guide walks through how ordinary refrigeration and condensation parts, the kind found in a mini fridge or window AC unit, can be arranged on a small scale to make that happen inside a household-sized build. The process itself unfolds in stages, not with a single unboxing moment. First comes gathering the parts, tubing, fittings, a small compressor, filtration elements, wiring. Items most builders can find at a hardware store or order online. From there, the videos walk through mounting each component in place, running and connecting the tubing, wiring the electrical connections, fitting the filtration stage, and securing everything into the layout shown in the diagrams. Each video segment lines up with a stage of the build, so a builder can pause, compare their own progress against the screen, and move to the next step once it matches. The guide is written for someone willing to work through each stage in order rather than skip ahead, using basic hand tools and everyday patience rather than an engineering background. Once assembled, the finished unit behaves less like a one-time project and more like an appliance that lives in the house. It needs a steady supply of electricity, since the refrigeration process that drives condensation doesn't run without power. For those wanting to keep it off standard grid power, the guide also outlines an optional setup running on batteries charged by solar panels, a path that calls for a few extra components beyond the core build. Like a dehumidifier or an air conditioner, it isn't something installed once and forgotten. Filters need swapping out on a schedule. The surfaces where condensation collects, along with the collection container itself, need occasional cleaning. Whenever it's running, its electrical components are drawing power, and how much water it produces on a given day shifts with the humidity and temperature in the room around it. The climate someone lives in becomes part of how the system performs, not a footnote to it. Because of that, using it feels different from turning a tap connected to city water or drawing from a well that's already flowing. Water collects gradually, gathering drop by drop while the unit runs under the right conditions. The guide's focus stays on that build and run process. It isn't positioned as a replacement for a home's existing plumbing or water supply. The people most likely to feel at home with Joseph's Well are the ones who already enjoy hands-on projects, tinkering with off-grid setups, working through preparedness plans, or just liking to understand how the systems around them actually work. Someone who's assembled furniture from a diagram, wired a project from a kit, or taken something apart just to see how it runs will recognize this format immediately, because the process of building it is as much the point as the finished unit sitting on a counter afterward. On the other hand, someone hoping to unbox a finished appliance and plug it in right away may find this isn't the right fit. The build isn't a step standing between the buyer and the product. The build is the product. In the same way, someone who'd rather hire a professional than handle assembly themselves will probably lean toward a manufactured atmospheric water generator or another existing household water system instead. Set next to conventional water sources, Joseph's Well occupies its own lane entirely. Municipal systems push treated water through existing public pipes. Private wells rise and fall with groundwater and depend on drilling. Rainwater systems depend on what falls from the sky and how much can be stored. Commercial atmospheric generators arrive fully built by a manufacturer. Joseph's Well, by contrast, hands over the instructions for building a smaller version of that same idea, one part at a time, from a garage or workbench. That difference runs through every part of the product. What arrives isn't equipment, it's information. Assembly stands in for a factory line. Sourcing parts stands in for a delivery truck. What comes out the other end, if someone follows it through, is something they put together themselves rather than something that arrived pre-built in a shipping box. None of these approaches cancels out the others. They're just different doors into the same larger question of household water access. Making sense of Joseph's Well starts less with whether pulling water from the air works and more with understanding exactly what this product hands over. It isn't a finished machine. It isn't a lecture about water independence, either. It's a digital guide for building a DIY atmospheric water generator from parts anyone can source, aimed at people who want to build that kind of system with their own hands. From there, the real question isn't about the concept anymore. It's about what the build actually feels like once the parts are laid out on the table. How closely does that hands-on process match what the guide lays out once the tubing is cut, the wiring is run, and the first drop of water hits the collection container? For anyone curious enough to find out, a link to Joseph's Well is in the description below.